Only 23 were ever built. Germany's first tank, the A7V, armed with a 57mm gun and crewed by 18 men, debuted at St. Quentin in March 1918. Within 2 years, the Treaty of Versailles banned Germany from building armored vehicles entirely. What followed was a century of engineering that produced every German tank ever fielded, from clandestine prototypes tested at secret Soviet facilities to a 188-ton super-heavy vehicle that never saw combat, to the Leopard 2 that still anchors NATO's armored doctrine. It all began with a design failure that German engineers refused to accept. The A7V, Germany's first operational tank, entered combat at St. Quentin in March 1918. Weighing nearly 30 tons and armed with a 57mm Maxim Nordenfeldt gun, plus up to 7 machine guns of 7.92mm caliber. The A7V's steel hull measured over 7 meters in length and stood more than 3 meters tall. Its 2 Daimler 100 horsepower engines delivered a top speed of just 8 kilometers per hour, and the vehicle's high ground pressure limited its ability to cross muddy or cratered terrain. Crew requirements reached 18 men, far more than contemporary British designs. In field conditions, the A7V's steering system proved unreliable, especially in wet or uneven ground, as documented by the October 1918 Waffenamt report, which highlighted persistent control failures under combat stress. Armor thickness ranged from 16 to 30 millimeters, offering some protection against small arms, but remaining vulnerable to artillery and anti-tank rifles. After the armistice and the Versailles ban on armored vehicles, German engineers shifted to covert development. The Reichswehr's design bureau, operating under the guise of agricultural machinery programs, initiated projects like the Leichtraktor and Großtraktor in the 1920s. These prototypes, built with lighter chassis and simplified suspensions, were tested in secrecy at the Kama facility near Kazan in cooperation with Soviet authorities. The Leichtraktor weighed around 16 tons, mounted a 37mm gun, and featured coil spring or leaf spring suspension. These were early attempts to solve the mobility issues that plagued the A7V. By the early 1930s, the Neubaufahrzeug, a multi-turreted 23-ton prototype, appeared. Although only 5 were built, these tanks were paraded in Oslo in 1940 as a propaganda tool rather than a serious combat asset. Their complex design and slow speed underscored the limitations of heavy, over-engineered vehicles. Each of these early projects informed the next generation. Lessons learned from the A7V's poor cross-country performance and the mechanical failures of clandestine prototypes led designers to prioritize mobility, lighter chassis, and more practical suspensions in the coming Panzer series. The technical and doctrinal groundwork laid in this period directly shaped Germany's approach to armored warfare in the years ahead. The Panzer I entered production in 1934 as Germany's first mass-produced tank, designed primarily for training under the restrictions of the Versailles Treaty. Weighing 5.4 tons, powered by a 60-horsepower Krupp engine, and operated by a 2-man crew, the Panzer I was armed with twin 7.92mm MG-13 machine guns. Its maximum armor thickness of 13 millimeters provided protection only against small arms fire. Krupp and Maybach factories in Essen and Friedrichshafen led initial assembly, with total production reaching 1,190 hulls between 1934 and 1936. An additional 2,000 chassis were later used for specialist variants. The Panzer I's first combat test came in the Spanish Civil War from 1936 to 1939, where it faced Soviet-supplied T-26 tanks. Field reports from Spain highlighted the inadequacy of its armament and armor, prompting a 1937 memorandum from the Heereswaffenamt that recommended immediate upgrades. The experience underlined the tank's limitations. Its machine guns could not penetrate even light armor at typical battlefield ranges, and the thin steel plating left crews vulnerable to anti-tank rifles and artillery fragments. Despite this, the Panzer I served as the backbone of early German armored units, providing essential training for crews who would later operate more advanced models. In response to combat feedback, the Panzer II was developed as a stopgap solution. Entering service in 1935, the Panzer II featured a larger chassis, a 3-man crew, and a 20mm KWK 30L55 autocannon paired with a coaxial 7.92mm MG 34. Armor thickness increased to 14mm on the sides and up to 30mm on the front hull, while the Maybach HL62 engine delivered 140 horsepower. Production totaled 1,856 units across multiple factories, including Krupp and Mayenne, from 1935 to 1943. The Panzer II saw action in Poland and France, where its 20mm gun was effective against lightly armored vehicles, but struggled against heavier French and British tanks. Both the Panzer I and II were quickly outclassed in direct combat, but their lightweight construction and mechanical simplicity allowed rapid mass production and deployment. The shift from machine gun to autocannon armament marked a critical evolution, driven by battlefield necessity. These early light panzers established the foundation for Germany's mechanized warfare doctrine, while persistent demands for greater firepower and protection set the stage for the integration of foreign designs and heavier domestic models. The annexation of Czechoslovakia in 1938 brought the German army immediate access to the Škoda and CKD tank factories, transforming the pace and scale of panzer production. The Panzer 35T, originally a Škoda design, entered Wehrmacht service with a 10.5-ton hull, 35mm of frontal armor, a 3.7cm KWK 35 TEL 45 gun, and a Sauerer 512 gasoline engine producing 150 horsepower. This chassis featured pneumatic brakes and a leaf spring suspension, supporting a top speed of 35 km per hour and a range of 150 kilometers. Between 1939 and 1941, 434 units were issued to German units, primarily equipping the 1st through 3rd Panzer divisions during the Polish and French campaigns. Early field reports noted a 93% operational readiness rate, but the pneumatic braking system proved vulnerable to freezing temperatures, leading to a sharp rise in immobilizations during the Russian winter of 1941. The Panzer 38, produced by CKD, was lighter at 9.7 tons, but offered 40mm of frontal armor and a 3.7cm KWK 38 TL-47 gun. Powered by a 120 horsepower Maybach HL62 engine, it reached 42 km per hour on roads and could operate for up to 200 km between refueling. The 38T's leaf spring suspension and robust gearbox contributed to a mean time between failures of approximately 540 km, considerably higher than the Panzer II. German-controlled production at CKD yielded 1,414 new vehicles, supplemented by 400 captured from Czech stocks, allowing the Wehrmacht to field 9 divisions with this dependable chassis by 1941. After action summaries from the Battle of France recorded less than 3% of the 38T fleet lost to mechanical breakdown compared to 9% for the Panzer III. Czech chassis accounted for roughly 30% of all German armored fighting vehicles on the Western Front in 1940, providing a logistical advantage through their reliability and immediate availability. The 38T in particular became the foundation for later self-propelled guns, including over 1,500 Marder III and 2,800 Hetzer vehicles by 1945. The flexibility of these designs allowed rapid conversion to tank destroyers and command variants, extending their utility well beyond the lifespan of the original gun tank. While the Panzer 35TE was phased out after 1941 due to brake failures and thin armor, the 38T chassis remained in production for specialized roles until the final months of the war, underscoring the industrial value of captured Czech technology in supporting Germany's early armored offensives. The Panzer III and Panzer IV became the backbone of Germany's armored force as the war escalated. Both were designed to balance firepower, mobility, and protection, and they evolved continually to meet new threats. The Panzer III began with a 37mm main gun and 15mm of armor, but it was quickly upgunned to a 50mm KWK 38 L42 and later the longer 50mm KWK 39 L60 as enemy tanks improved. Armor thickness increased from 15 mm to 50 mm on the later StuG models and beyond. Powered by a 300 horsepower Maybach HL120 TRM, the Panzer III reached speeds up to 40 km per hour with a 5-man crew, commander, gunner, loader, driver, and radio operator, enabling coordinated action and rapid communication. Production reached 5,774 units between 1939 and 1943, with major assembly at MAN and Deutsche Werke plants. The Panzer IV started as an infantry support tank, fielding a short-barreled 75mm KWK-37 L-24 gun and 30 mm of frontal armor. As the conflict intensified, the design shifted to a more versatile role. By the IUSFG model, the Panzer IV carried the long-barreled 75mm KWK-40 L-43 or L-48, capable of penetrating 80 mm of armor at 1,000 meters. Frontal armor reached 80 mm, and the Maybach HL120 TRM engine provided 300 horsepower for a top speed of 38 km per hour. Like the Panzer III, the Panzer IV featured a 5-man crew and a central radio, which allowed for flexible command and control on the battlefield. Production exceeded 8,500 vehicles from 1937 to 1945, with Krupp and Nibelungenwerk as primary manufacturers. Both tanks were continually upgraded in response to Soviet T-34s and Allied Shermans. Their modular hulls and standardized components supported the rapid development of new variants, including command tanks and observation vehicles. The 5-crew layout and radio integration gave German units a tactical edge in maneuver warfare. As the war dragged on and resources tightened, these chassis became the basis for turretless assault guns and tank destroyers, a shift that reflected both battlefield necessity and industrial constraints. The transition from turreted medium tanks to simpler turretless designs would define the next phase of German armored production. The Sturmgeschütz III, or StuG III, became the most produced German armored fighting vehicle of the Second World War, with over 10,000 units built between 1940 and 1945. Developed by Alkit in Berlin, the StuG III was based on the Panzer III chassis, but replaced the turret with a fixed superstructure mounting a 75mm StuK 40L48 gun. This turretless design reduced manufacturing time and material costs, allowing German industry to deliver armored fire support at scale, even as resources dwindled. A crew of 4 operated from a low, compact hull with frontal armor up to 80 mm, providing better protection than many turreted contemporaries. Initially intended for infantry support, the StuG III evolved into an effective tank destroyer as its main gun was upgraded. The Waffenamps conversion policy extended the concept to the Panzer IV chassis, resulting in the StuG IV. Production began in late 1943, with around 1,100 vehicles assembled by Alkit and Krupp by war's end. The StuG IV retained the 75mm StuK 40, but its slightly higher profile and increased weight offered only minor tactical differences from the StuG III. Both models shared the advantage of simplified assembly, eliminating the turret ring and rotating mechanism and allowing factories to repurpose existing hulls rapidly, especially after Allied bombing damaged turret production lines. The Brummbär, or Sturmpanzer IV, represented a specialized assault gun role. Debuting at the Battle of Kursk in July 1943, the Brummbär mounted a 150mm StuG 43 howitzer in a heavy casemate on the Panzer IV chassis. Weighing 28.2 tons and crewed by 5, its thick frontal armor, up to 100 mm, was designed for urban combat and bunker reduction. Only 306 Brummbärs were built, reflecting its niche use in battles such as Warsaw and the Siege of Leningrad. These turretless assault guns provided the Wehrmacht with cost-effective firepower, enabling mass deployment despite growing material shortages. The priority given to StuG production by the Ministry of Armaments underscores their industrial and tactical importance. This approach set the precedent for further adaptations, as German planners increasingly favored casemate tank destroyers and self-propelled guns over traditional turreted tanks. As the Eastern Front exposed the limits of existing German armor, engineers turned to rapid improvisation and experimental prototypes to restore anti-tank capability. The VK-1602 Leopard stands out as an ambitious 1942 reconnaissance project. Designed by Krupp and MAN, it featured a projected weight of 21.9 tons, a Maybach HL 120 TRM engine delivering 300 horsepower, and a planned top speed of 45 kilometers per hour. The Leopard's 50mm KWK 39 L60 gun and wide 660mm tracks, later influential in Panther development, were intended to offer both firepower and mobility. However, its excessive weight and persistent engine overheating led to cancellation before mass production. Design elements, especially the wide track suspension, were directly passed on to the Panther series, linking experimental concepts to frontline vehicles. In parallel, the Wehrmacht pressed existing chassis into anti-tank service. The Marder family emerged as a stopgap response. The Marder III, built on the Czech Panzer III chassis by CKD, mounted the 7.5cm PaK-40 anti-tank gun in an open-topped fighting compartment. Weighing 10.5 tons and crewed by 4, the Marder III offered firepower capable of penetrating 150mm of armor at 500 meters, but its thin armor, 30mm at the front, and exposed crew made it vulnerable to artillery and small arms. Production reached 1,511 units between 1943 and 1945, illustrating the urgency of fielding effective anti-tank platforms despite limited protection. A more refined solution appeared with the Panzer 38T, known as the Hetzer. Also manufactured by CK, the Hetzer featured a fully enclosed, sloped casemate mounting a 7.5cm PaK-39 L48 gun. At 15.75 tons, with a 4-man crew and a top speed of 42 kilometers per hour, the Hetzer's 60mm frontal armor sloped at 60 degrees provided substantial protection for its size. Its low silhouette enhanced survivability, while production accelerated to 2,827 vehicles from March 1944 to April 1945, even under severe material shortages. The Hetzer's compact, efficient design became the benchmark for late-war German tank destroyers, setting a performance standard that heavier casemate vehicles would have to exceed. These interim solutions highlight how German industry relied on rapid adaptation, using proven chassis and available guns to keep pace with evolving threats. The technical lessons and production experience from the VK-1602, Marder III, and Hetzer directly influenced the next generation of heavy tank destroyers and set the stage for the escalation in armor and firepower that followed. Tiger I, Panther, and Tiger II marked the apex of German turreted tank engineering, each revealing the tension between armor, firepower, and mechanical limits. The Tiger I, entering North Africa in late 1942, weighed 54 tons and carried the 88mm KWK 36L56. Its 100mm frontal armor allowed it to knock out Allied Shermans at Sidi Bou Zid before they could respond. Yet its 700 horsepower Maybach engine struggled, with a mean time between failures of just 12 hours, often leaving crews stranded during maneuvers. The Panther, designed by MAN and first seen at Kursk in 1943, featured a sloped 80mm glacis and a top road speed of 55 kilometers per hour. Panthers destroyed T-34 tanks at long range, but early models suffered from transmission breakdowns. The Tiger II, or King Tiger, appeared in Normandy in 1944 with 150mm glacis and the long 88mm KWK 43L71. Its nearly 70 tons and an unchanged Maybach engine pushed reliability and mobility to the breaking point, forcing engineers toward turretless heavy tank destroyers. Krupp engineers redefined anti-tank warfare with heavy casemate destroyers built for long-range kills. The Nashorn, fielded in 1943, mounted the 8.8cm PaK-43 L71 on a Panzer IV chassis. Its open compartment and thin 30mm of armor were offset by a gun that could pierce over 200mm of steel at 1,000 meters. Crews relied on distance for survival, as the high profile made them easy targets. The Ferdinand, later known as the Elephant, brought 200 millimeters of frontal armor and the same powerful gun. But early versions lacked a hull machine gun, leaving them exposed to infantry until the MG-34 was added. Weighing 65 tons, the Elephant's bulk and mechanical issues limited its mobility. The JAG Panther, with sloped armor and a lower silhouette, struck a better balance of protection and firepower. The JAG Tiger, armed with a 128mm gun and 250mm of frontal armor, was nearly impervious, but slow and prone to breakdowns. Each design traded tactical flexibility for raw firepower and protection. The MAOS, at 188 tons, stood as the heaviest tank ever tested. Its 128mm KWK 44L55 main gun and 220mm of frontal armor were designed to defeat any Allied fortification or armored vehicle, but the tank's immense weight made it nearly immobile in the field. Test reports from 1944 recorded a top speed of just over 20 kilometers per hour and persistent failures in the drivetrain. Only 2 prototypes were completed before the project was halted, and both were captured before seeing combat. The E-100, intended as a 100-ton platform for a 150mm gun, never advanced beyond a single incomplete hull. These super-heavy projects exposed the limits of armor and firepower when mobility and logistics could not keep pace. Post-war, German designers abandoned the super-heavy concept. The Bundeswehr's Leopard 1, entering service in 1965, weighed 42 tons, less than a quarter of the MAUS, and prioritized speed and agility. Powered by an 830 horsepower MTU diesel, the Leopard 1 reached 65 kilometers per hour. Its 105mm L7 gun aligned with NATO standards, and armor was limited to 40mm of steel, reflecting a doctrine shift toward maneuver and survivability. The Leopard 2, introduced in 1979, pushed this evolution further. A 120mm smoothbore gun, advanced composite armor, and a 1,500 horsepower engine gave it both superior firepower and a top speed of nearly 70 kilometers per hour. These tanks, built by Krauss-Maffei, incorporated lessons from wartime failures, standardized components, modular protection, and an emphasis on reliability. The transition from the MAOS to the Leopard series marks a clear break from the pursuit of mass toward a balanced main battle tank, shaping the modern legacy of German armored design. Today, the Leopard 2 stands as NATO's most widely fielded main battle tank, directly reflecting a century of continual German armored design evolution. Technical innovations, doctrinal shifts, and battlefield lessons from every preceding model inform its current role. As modern conflicts demand rapid adaptation, the legacy of German tank engineering remains central to the future of armored warfare. Technical progress never halts. Its consequences echo on every battlefield.